Hello and welcome to our training session, information session for our course offering in 2025. We'll briefly go through the training options that Secat provides, the classes that we're going to be offering in 2025. If you're not familiar with Secat, we are a metallurgical testing and research lab that was founded in 1999 to support the aluminum industry. And we still hold on to that mission to support and help develop the aluminum industry. And part of that includes providing comprehensive training classes on process and metallurgical aspects of manufacturing aluminum from ore to end-of-life recycling. So we have some of that content in each one of these, and in these training classes, particularly our certificate program, and we'll discuss what all is included in each training option in 2025 and who the target audience is for those classes. If you're not familiar with Secat, we are owned by the University of Kentucky, but we operate independently from them. But we do have some faculty that participate in our training programs from the University of Kentucky. We're located in Lexington, Kentucky, and our training classes that are on site are all here in Lexington. We do have a pilot scale facility in Nicholasville, which is about 40 minutes south of Lexington. We use that during our certificate and other enrolling class to provide actual hands-on demonstrations. So with that, we'll go into the classes. The certificate class is something we launched 2 years ago, so this will be our third class. It's a smaller class. We cap the number of seats at 8 so that we can get optimal learning experience, but also because it's a hands-on class. So for the students get to do casting, rolling, forging, heat treating, microscopy, tensile testing. So, the course is set up so we spend about half a day doing lectures in the classroom, and then the other half doing experiments in the laboratory environment. So that includes the pilot facility as well as the laboratory in Lexington. So because of that hands-on learning experience, we cap it at 8 students. So if you're interested, reserve those seats early. The certificate includes 4 week-long classes that are listed here: aluminum casting, deformation processing, thermal treatments, and testing and properties. So each one of these modules has to be taken to receive the certificate in aluminum metallurgy. Now, you don't have to take all of them in 1 year. You can stretch it out over 2 or 3 years if you'd like. But of the students we've had so far that have graduated with their certificate in aluminum metallurgy, all of them have taken it all in the 1 year period. So that has seemed to work well. So we'll go through each one of these modules. Each module is $5,000 per student per week, per module. So the total cost of the certificate program is $20,000. So it's a big expense, and it's a big time commitment. So it's really geared towards folks that are either new engineers that are working in the aluminum industry. They could be metallurgical engineers or materials engineers or chemical engineers that are working in a lab or in a process or a quality role at a aluminum manufacturing facility. Or it might be someone that's worked in the aluminum industry for 10 or 20 years and has worked their way into a more managerial type role where they're having to manage processes and they need to understand how those processes or upstream or downstream processes affect the product. So we launched it to targeting those 2 demographics. But the other reason we launched this certificate program 2 years ago is because there is a need for this comprehensive aluminum metallurgy education in the industry, for professionals that are working in the aluminum industry, partially because, to our knowledge, there are no university programs that offer this curriculum anymore because of the size of the class. Classes are typically too small. When I was an undergraduate at Michigan Tech, they had this class, specifically aluminum metallurgy, a semester-long class. They don't offer it anymore because there were only 3 or 5 people in that class. So not only does it supplement what's needed in the industry, but it supplements what's not being provided by the universities anymore because the demand is too small. And so it's been highly successful over the past 2 years, and we're excited to launch this third one. It's evolved slightly over time, but these 4 core classes are the basis of it. And so, yeah, aluminum casting is the first module, and this will be offered in March of 2025. So the way the aluminum casting is set up, we cover 2 days on shape casting and 2 days on wrought alloy casting, 2.5 days on wrought alloy casting. I should say each one of these classes is 4.5 days, so it's generally from 9 to 5 Monday through Thursday, and then 9 to 12 on Friday, so that people can travel home safely on Friday afternoon. But the aluminum casting course, like I said, 2 days to 2 days on shape casting, 2.5 days on wrought casting, and some mixed in between of microstructure or analysis or laboratory tensile testing. But the focus is on both, to cover all aluminum alloys, not just one class or the other. And we also talk about distinguishing features, metallurgical features of a casting alloy versus a wrought alloy. And then our last half a day is on sustainability, and we have Professor Badr-Din, who's a faculty member at the University of Kentucky, talk about that area. Because Secat's not as strong in the shape casting area as we are in wrought casting, we supplement that curriculum with 2 guest lectures. David Weiss of Eck, he retired from Eck after a long career, and now he has his own consulting company called Vision Materials. So he talks about sand casting and kind of the mold making and casting process. And then Dr. Alan Lowe of the Ohio State University, he covers die casting of aluminum specifically, and also touches on integrated computational materials engineering. So for all of the classes, it's a mix of Secat staff as well as guest lecturers who are experts in their specific fields. And most of the guest lecturers fill in on areas that Secat staff members aren't as strong. But either way, it gives a more broad perspective to the students, and it seems to help with engagement. So the objectives of the aluminum casting course, we want to understand the wrought and aluminum alloy systems, the designations, and what are the different alloying elements. And we'll hit on that throughout all 4 classes, so that that's really honed in by the end of the program. We do molten metal, charging, filtration, degassing, shape casting, sand, permanent mold die casting. We learn about direct chill, ingot, and billet casting. We look at on the shape casting, the effects of cooling rate and grain refiner. Do hands-on testing of hydrogen and inclusion. So we pull and then again, a brief exposure to recycling, emission sustainability, and tools for computational simulations. So the hands-on work, we do 2 modules. One is doing a shape casting with a permanent mold, and we look at different section sizes and the effect of grain refiners and cooling rate on the microstructure and tensile properties of that permanent mold. And then the other section, we have pilot facilities to do direct chill billet casting. So we cast a 10-inch diameter billet Last couple of years, it's been 6005. And during that casting process, we pull samples for we do a hydrogen measurement, and we pull samples for PODFA to look at the inclusions in the melt. So our pilot facility is set up just as if it were a small, full-scale cast house in industry. So we get to see, up close all of the process of the direct chill casting. The second module covers deformation processing. So this is mainly rolling, forging, and extruding. We do also hit on stamping and joining in this section. In addition to Secat staff, we have 2 guest lectures for this one. This class is the week of June 2nd. And so Scott Goodrich, he helps us quite a bit with our flat rolled product training classes. So you'll see his name a few times in this presentation. He does the rolling section of the certificate program, and then Dr. Wojciech at Lehigh University, he gives his lecture on extruding. And we're excited this year because we have a new pilot scale extrusion press that we'll be able to supplement with demonstrations, supplement Wojciech's lecture with demonstrations on extrusion processing. The other thing that we do in deformation processing is we cut smaller billets out of our bigger 10-inch billet, and we forge plaques that will carry through we will carry through in the certificate program, and at the end of the year or the end of the completion of the program, you get to take that plaque home. So the learning objectives for deformation processing, we want to learn about the hot and cold rolling processes and how the microstructure evolves throughout the process. Understand the forging process and different equipment, same with the extrusion process. And through all of it, we're looking at how the microstructure and metallurgical features of the product evolve through the thermomechanical processing. We demonstrate the concept of flow stress, which determines the loads and tonnages on the presses or mills that are used to form the metal. And then we really highlight different defects in each of the processes. And then we have the last day we discuss stamping, drawing, joining, and fabrication of flat roll products.